friends. Here we are going to start the concepts for the analyticity, all the definitions and the important points which are very helpful in UGC NET exams also. So let's start with the definition for the analytic function. A function fz is said to be analytic or holomorphic at a point z0 if it is differentiable everywhere in some neighborhood of z0. If the function is differentiable everywhere in sub-neighborhood of z0, we said that the function is analytic, right? So this is the point z0 and this is the neighborhood of z0. So this is about a function which is analytic at the point z0, right? And now we are going to talk about the function is analytic in the domain D. A function fz is said to be analytic in domain D. If this is the function, this is analytic in this domain D. If it is analytic at every point in the domain. If it is analytic at every point in the domain. So these are all green colored points in the domain. If the function is analytic at every point in the domain, we say that the function is analytic in the complete domain, D, right? Let's say the domain is D. Next, the entire function. A function analytic at every point in the complex plane is called an entire function. For example, the function sine z, cos z, exponential functions, all these are the entire functions. These are analytic at every point in the complex plane. Next, the remark. The function fz, a very common function I am going to take here. The function fz equal to mod z. What is mod z? It is x square plus y square under the root. This function is not differentiable only at the origin and hence not analytic everywhere because it is not differentiable only at the origin. Only at the origin it is not differentiable. So we say that this is not analytic everywhere. Second, now if I take the function fz as x square y square, this is differentiable at all the points on each of its coordinate axes but is still nowhere analytic because CR equations are not satisfied. CR equations, the Cauchy-Riemann equations, are not satisfied for this function. So that is why we say that even if the function is differentiable at all points but on each of the coordinate axes, the function is still nowhere analytic because CR equations are not satisfied. Third point, please remember that all polynomials are entire functions. Also, sine z, cos z, such kind of functions are also the entire functions. Then is, if I take the function of the kind 1 divided by 1 minus z, this is analytic everywhere. How do we say this? This function is analytic everywhere except at the point where this denominator is 0. If I take the denominator to be equal to 0, I am getting z equal to 1. So except at the point z equal to 1, the function is analytic everywhere. So whatever function you will be having, that function will be analytic everywhere except the point where the denominator is 0. Next, a very important remark. If fz is analytic at z0, suppose this is the point z0, then there exists epsilon positive such that fz is differentiable at every point in the neighborhood of z0. This is the epsilon neighborhood of z0. Epsilon neighborhood means the neighborhood of z0 is having the radius epsilon. So they are saying that if fz is analytic at the point z0, then there exists epsilon neighborhood of z0 such that this function is differentiable at all the points of the neighborhood of z0. But for a point, let's say z1 belonging to the neighborhood of z0 and z1 is having the neighborhood with the radius delta, right? We can find delta positive, the radius of z1, we can find delta positive to be the radius for the neighborhood of Z1 such that this is the neighborhood of Z1 with delta radius, such that this neighborhood is the subset of this bigger neighborhood, the neighborhood of Z0. Then delta neighborhood of Z1 is the subset of epsilon neighborhood of Z0. So what would we conclude from this? If this fz is differentiable at all the points of this bigger neighborhood, can we say that the same fz is differentiable at all the points of the smaller neighborhood? Yes, because it is a subset of the bigger one, right? So we write further that fz is differentiable at every point in delta neighborhood of Z1, and hence because it is differentiable at every point of delta neighborhood of Z1, the smaller neighborhood, we say that fz is analytic at Z1. So we say that the same fz is analytic at Z1 also. Right? So for the analyticity of the point, the function must be differentiable at all the points of some neighborhood of that point. Right? So consequently, we say that please take this as your remark. Fz is analytic at a point if and only if fz is analytic in some neighborhood of that point. So it is a vice versa. If the function is analytic at a point, then it is analytic in some neighborhood of that point also. And if the function is analytic in some neighborhood of the point, then we say that the function is also analytic at that point. It is a vice versa, right? Next, again one remark very important. Thus, we can also say that from the previous concept, set of all values for which a given function is analytic must form an open set. Why? Because neighborhood itself is an open set. Yes, the neighborhood of the point is an open set. So the set of all values for which a function is analytic must form an open set. In particular, if the function is analytic in a closed set, suppose this is your closed set. If a function is analytic in a closed set, this C, the closed set, then there is always an open set that contains this closed set in which the function is analytic. There is always an open set enclosing this closed set in which the function is analytic. It is very important point. If we are saying that, if you say that function is analytic in closed set, then there is always a bigger open set containing that closed set in which the function is analytic. If fz is defined in an open set G, then fz is analytic in G if and only if it is differentiable in G. Right? If we are having the open set named as G and the function is defined in this set, then fz is analytic in G if and only if it is differentiable in G. Second point, every polynomial is analytic in C. Third, if fz equal to 1 by z, where z is non-zero, is analytic in C. Remember, I have also defined a function fz to be 1 divided by 1 minus z. When do we say that this function is analytic? At what points we say that this function is analytic? All the points in the complex plane except where the denominator is 0. That is where z is equal to 1. Similarly, for this function also, where the denominator is 0, that means at the point z equal to 0, the function is not analytic. So except this point, the function is analytic in the whole complex plane, right? Next, so this is all about the definitions and few remarks, very important ones, which are very helpful in the UGC NET exams. So please go through these. This is very important. Okay, thank you. Stay blessed.